Very good afternoon. I am architect Namrata Mahal. On behalf of GRIHA Council and UNSW Sydney, I would like to extend a warm welcome to all of you. Before we dive deep into today's session, let us get acquainted with the safety arrangements in Stein Auditorium. TERI is a quality, health, safety, and environment certified organization. In case of any untoward incident like fire, needless to say, evacuation is required, and we have 4 exit gates over here, 2 on my left, 1 on my right, and 2 at the back. And we have an exit gate, 2 exit gates on the top in the balcony. You are required to exit from this auditorium in case of fire. The fire marshals will take their positions in aisle and help you evacuate. With that note, I welcome you all for today's plenary session, Energy Challenge. The word challenge offers multifarious opportunities to increase the use of renewable energy and at the same time offset the energy consumption by efficient design of the built environment and systems, while strengthening the institutional regulations and policies in promoting low carbon living in urban India. Today's session will deliberate on taking an integrated approach to the energy challenge while discussing the issue of energy access, kind of technologies, investments, and infrastructure that are required to power India's fast-growing cities. With that note, I would like to invite all our esteemed speakers and moderator of the session to please come on the dais. With us, we have Professor Prasad, CEO of CRC-Low Carbon Living Built Environment, UNSW, the moderator of the session. Mr. Abhay Bakre, Director General of Bureau of Energy Efficiency. Mr. Pramit Patel, Business Development Manager of Gujarat Guardian Limited. Mr. Saurabh Kumar, Managing Director, Energy Efficiency Services Limited. I think we don't have Mr. Kumar over here. Mr. Ashwani Pahuja, Chief Sustainability Officer and Executive Director, Manufacturing at Dalmia Cement. Dr. Anna Agarwal, Fellow, Center for Policy Research. Mr. Sanjay Seth, CEO of GRIHA Council. A warm welcome to all of you. I'm going to trouble you again for a minute that you'll have to come at the front for a group photograph, sir. Meanwhile, I'll introduce the moderator of the session. We have Professor Prasad. He is a national leader in the field of energy, carbon in buildings and cities. This is evident by every level recognition that Sir has from the city, state government, federal government, Institute of Architects, and the Academy of Technological Sciences and Engineering. His order in Australia is at the level of Padma Vibhushan in India. Sir has published more than 300 referred publications, including 7 books in the area. Most recently, he has been the Chief Executive Officer of the CRC for Low Carbon Living, a national research innovation hub for the built environment. This has been a highly successful center which has delivered significant carbon reductions while enabling more than $1 billion Australian economic impact in the country. May I welcome you, sir. You want to briefly introduce him? You want to briefly introduce everybody? So maybe I'll introduce quickly to everybody and then you take it over. So what I'll do, I'll quickly introduce all the speakers and then my job ends and sir is going to take it over from me. So with us we have Mr. Abhay Bakre, sir. He's the Director General of Bureau of Energy Efficiency, Government of India. His priority at BEE is to accelerate flagship programs such as PATH scheme for industry sector and adoption of building sector efficiency at state level. Before joining BEE, he has worked as Executive Director in the Ministry of Railways and he was Nodal Officer for GHG reductions in Indian Railways. We welcome you, Abhay, sir. Mr. Pramit Patel is a Business Development Manager at Gujarat Guardian Limited. Having more than 17 years of experience in cement and glass industry, he has been recognized as a solution provider, assisting project owners to make right choices when it comes to glass. To his credit, he is a ECBC master trainer and also a certified GRIHA professional. We welcome you, sir. With us, we don't have Saurabh Kumar, sir. We move on to Mr. Ashwani Pahuja, sir. He is the Executive Director and Chief Sustainability Officer with Dalmia Cement. He is leading the climate commitments and mitigation actions being taken up through initiatives such as new product development and technology advancement. Mr. Pahuja has over 39 years of experience in building materials sector. He's a co-inventor in 16 patents and has published more than 81 technical papers in national and international journals. We welcome you, sir. With us, we have Dr. Anna Agarwal. She is a fellow at Center for Policy Research Initiative on Climate, Energy and Environment. Her research is on undertaking India's energy demand transitions and identifying ways to lock in low carbon energy consumption patterns for the long term. Her work currently focuses on residential electricity demand, particularly the cooling demand, which could be a substantial driver for future energy needs and carbon emissions. Prior to joining CPR, she was the Associate Director at the Urban Innovation and Senior Fellow at the Energy Policy Institute at the University of Chicago. We welcome you, Dr. Anna. Mr. Sanjay Seth, of course, I need not introduce my boss, but yes, I'll do with a very, very impactful line that sir has got more than 33 years of experience in power sector, both on demand side and supply side manager, and he keeps us always on the toe to do the job that we are doing right now. So we welcome you, sir. With this challenging task of very briefly introducing all our speakers with such high profile, I give it over to Professor Prasad to take it forward. Thank you, sir.
Thank you. Thank you very much. You've done large part of my work already, so I can just get on with the presentation. I think because of the late start, we have some time constraints, so we should be moving quite quickly. I will give a brief overview and then we'll follow the sequence of talks that have been introduced. So, rapid urbanization, a lot's been said. Energy is a large part of that challenge. The focus, the theme around the talks today is integrated approach to sustainability. And cities very clearly are most amenable to an integrated approach. It's very, very difficult to achieve outcomes in a siloed approach. So when we talk about resilience, some people have talked about resilience, urban microclimate, how do you design, plan, integrate these things. A lot of talk about smart, sustainable cities, community well-being, livability in cities at the same time. All these things you cannot just do in isolation in bits and pieces at a time. So the integrated approach that has been made a thematic of this conference is pretty well thought through. When we look at cities and energy in particular, we see that historically, long time back, cities, the wealth associated with ever-increasing ecological footprint, if you like. So more people used carbon-based energy and so forth, and carbon and climate change was not an issue. More recent times, sustainable cities and regenerative cities have come into the mainstream thinking. And the idea behind good design planning technologies is to relate wealth around those parameters. So by designing, planning regenerative cities, we should be able to do it not only economically, but as part of wealth generation for cities, because cities are a major part of the wealth of a nation. You probably all know about the Sustainable Development Goals, 17 of them. They're all interconnected. So integrated approach to delivering on those have also become very well understood. We look at cities, and as I mentioned earlier, they are the growth engines of every nation, and it is very important to make sure that in driving sustainability and environmental quality of life and competitiveness from an economic point of view, that you get the balance right, so that it's not just extreme of one at the expense of the other. So looking at an integrated way where you get your balance and priorities right is very important. We're going through a point in history at the moment. Historically, greenhouse gas emissions, largely due to energy, were directly connected with the national gross national product, if you like, the total national income. More recently, in the last decade or so, they have started separating, decoupling, and now you have economic growth happening measurably without a consequent increase in greenhouse gas emissions. So that's a very good sign that we can achieve economic outcomes without really having too much in terms of pollution and impact. Also, the ambassador from Denmark, I think this morning, mentioned people and behavior side of things. That is very, very important all along the way. And in his country, there is very clear evidence of behavioral change beginning to take fold. So the number of bicycles on the road, if you like, has been increasing, whereas the cars have been decreasing to the point where there are now more bicycles on the road than cars. And that's because of the mindset, the behavior change that's beginning to kick in. And it's not just about improvements in technology, but changes in behavior. One of the key changes that we talk about, and I'm sure our panelists will talk more about, is photovoltaics, renewable energy. And there's clear evidence globally of this increasing. And particularly in cities. Cities is where the demand is, and that's where most of the energy is needed, and that's where you have a lot of roofs and surfaces where you can put these things up. In Australia itself, we had 7 gigawatt peak of rooftop photovoltaics just a few years ago, and it's increasing at 40% a year. So, and that's we had a very good feed-in tariff, which kick-started this change. But now it's been taken out, and there is the same normal increase in the use of photovoltaics without those feed-in tariff now, because of other factors, social factors, behavioral factors have kicked in. So that's looking good. My Vice Chancellor this morning talked about UNSW's credentials. We have significant research development capability at the university, but also as an institution, we have gone 100% off-site PV. We looked at efficiency on campus, we then looked at on-site generation, and then looked at outsourcing for the campus needs. So using poles and wires that's out there, we bring electricity from a very large solar farm about 1,000 kilometers away. So that's kicking in, and that's actually offsetting 100% of the electricity needs. Time of day is a problem, and the grid is the backup storage. So that's really one of the leading activities. The building I work in, and as a showcase building for energy, it's a 6-star equivalent, platinum, but it generates a whole lot of electricity other than other forms like ground coupled and dry gen, and all these parameters have been tried. But the building also houses a photovoltaic center, which is one of the largest in the world, led by a colleague of mine, Professor Martin Green. So anyone studying photovoltaics will have read a book by Martin Green. So in addition to looking at technology development, we also do a lot of research within the centers at UNSW on looking at impacts of climate change, really at a granular level, looking at how microclimates are changing and what mitigation strategies might be applicable. And basic things like greenery, urban landscapes, water bodies, cool roofs, cool materials, cool paints, and so forth, and the combination of those, to what extent it can mitigate, so that not only you have discomfort problems that you are trying to deal with, but you're also trying to deal with energy, cooling load in buildings problems over time. Of course, greenery and urban landscapes pretty important. We have taken some of these ideas forward into what we call living laboratories for the granular studies. So we did a large development in Perth, Western Australia, where we looked at zero carbon communities, planned, designed, built, and operated, fine-tuned with on-site efficiencies, and of course, looking at on-site generation, community storage, and then outsourcing purchases and so forth. And this is about 100 houses at a time. And this test bedding has been a great experience. Out of that, we have produced products like the Power Ledger, which is peer-to-peer trading platform in blockchain. And you see it won a major award in Davos, the World Economic Forum award given by Richard Branson for a student project, which is now floated, and it's a company that's selling it to the world. There's about 6 countries are using a platform like that. It really suits cities where a whole suburb at a time can actually turn towards renewables. A lot of our work is, the success is measured by impact. So we have done a house to about 100 houses at a time, from which we collected evidence, and governments, in this case, the launch of a Victorian zero carbon housing policy by the minister there in the middle of that photograph, with some of our researchers trying to take it into policy, because when evidence goes to policy, you can start having large impacts. My own state, New South Wales, has established with us a energy efficiency decision-making node, which has been in operation for 4 years now. We do the research and provide the evidence, government takes it on and changes into policy, and then we measure the impact of that in terms of reductions in carbon and so forth. We also looked at photovoltaic systems themselves. We know, and there's a lot of speculation that there is a deficit in terms of predicted generation and actual generation, and we developed a tool that remotely measures the actual real-time generation, and as a result, if there are faults, if there are breakdowns and something's wrong, it's underperforming, then the company actually informs the owners. So that's now in about 6 countries, and a lot of utilities are using it. At city level, we are able to now benchmark, monitor, and track changes in terms of whole citywide carbon footprint using the standard ISO standards scope 1, 2, and 3 methodologies globally used. We can actually track level of carbon in cities. So tools like these have been really good. Someone mentioned waste materials and use of fly ash from electricity generation. We have developed geopolymer-based products which are now being sold internationally, and this company, Wagner's, has a joint venture in India through which it's now selling geopolymer products in India as a replacement for high carbon content concrete. We're looking at not only PV, but PVT, getting heat out of PV at the same time. We have dealt with developing business case and technical case for changes in building code, which through instruments like that drive change. And these are all possible through good research, high quality research. We applied those to City of Sydney for a 70% targeted reduction in carbon. And they now are expecting to reach that point well ahead of time. So integration, as the thematic suggests, is a key part of that. Unless you have an integrated approach, it might take much longer. And good research and development that underpins this is absolutely essential. Collaborative, getting governments, research providers, and industry all on board. And that's the center I lead, which is a collaborative research center which delivers on a lot of these opportunities, products, technologies, and takes it out to impact. So with that, I would now call the next speaker, and I presume someone will change the slide. Thank you.
Abhay.
So, good afternoon, dignitaries on and off the dais. It is pleasure and honor for us as a Gujarat Guardian Limited to welcome you all in this 11th GRIHA Summit. At Guardian Glass, one of the key philosophy that we have that says, always see what's possible with the glass. This keeps us constantly innovate our product and services with respect to various performance standards. Working closely on this philosophy, we have been able to create several unique mega and sustainable structures across the globe, and many more are in making as well. This includes the current tallest Burj Khalifa in Dubai, which is cladded with the Guardian glass, and also the upcoming tallest, which is Jeddah Tower, also known as Kingdom Tower in Jeddah, to be cladded with Guardian glass. We have started our project journey in India a couple of years back, and we have been able to participate in certainly some beautiful structures in India as well, which are sustainable and green. This includes a currently ongoing project, Surat Diamond Burj in Surat, which is cladded with Guardian glass, DS Neutral 40, which is, if you talk about Surat Diamond Burj, it is again world's largest commercial complex in a single building category. So we have set up a landmarks across the globe, and now we are coming to India and starting creating such landmarks as well. I will take a moment to introduce ourselves. We as a Guardian Industry is a US-based company. We are among the major leading float glass manufacturer. We have 26 float line across the globe and 22 coated line across the globe. With this 22 coated line, we are the world's largest coated glass manufacturer. When we say coated glass, it essentially refers to the glass that we use onto our building facades and fenestration when it comes to sustainable building. In India, we are known as Gujarat Guardian Limited. It is a JV between MODERATOR Limited and Guardian Industries USA. In fact, we are the first float line of India. So we are operational since 1993 in India. And we are also credited with to launch the first lead-free mirror in India. Since then, we have been a market leader in the mirror segment as well. We have started our coated glass manufacturing somewhere last year around March, and we have been involved in doing projects with now our locally manufactured coated glass. So coming back to how we contribute to the project with respect to our products. Essentially, it is revolving around our most advanced, technologically advanced coating, which touches various aspects of the glass, starting from the performance to aesthetic to processability to durability and well-being part as well. So I'll not talk about all of them listed on this slide, but I'll briefly touch upon a couple of them which are crucial from an Indian market perspective. One of them is color rendering index. It essentially deals around aesthetics, but it is very critical for India. Most of the glass are coated on clear substrate, whereas we have seen in Indian market there are many of the coatings available which are done on the tinted substrates. So essentially, what is the difference? And at the top right, you can see when you see through the glass and try to connect to the world outside from your building, the top right picture, the one picture depicts how you see the world from our clear coated glass, and the another is with the tinted coated glass. And you can clearly see the world gets the tint of the color of the glass. So essentially and that is true for the light that is coming inside the building as well. So whenever the light is coming inside and you have used a tinted coated glass, the light gets the color of the tint of the glass. But as all the coatings are on clear based, you get the neutral light. So to summarize, an architect wants to have the building that looks blue from outside, but essentially what he wants from inside is to look neutral, as clear as possible. They don't want a blue looking building from the inside as such. So that is one critical advantage or a USP that a Guardian coating can bring. Another one that I would like to highlight is the wide range of product with Guardian glasses, Guardian Sun Guard. How it helps, we have seen many a time a case when people comes to us and say whether your glass is green rated or not. And our answer always is yes, but it depends. It depends on so many factors, starting from climate to orientation to sun path analysis to a daylighting requirement of your project to a perimeter depth and so on. So we understand that every project has a different requirement. Every project may have a different performance requirement. Every project may have different aesthetic requirement. So here we are offering a widest range of coated glasses to choose from, wherein you can essentially choose the performance level required for your project, the aesthetic you are looking for your building to have, and you have the right product on hand to work with. So not only from the product side, but we also support from the services part as well. So how do we do that? Essentially, we provide various reports that includes but not limited to structural reports, acoustic reports, performance report, energy report, and so on. We also provide a 3D rendering works as well, which is essentially applying our glass optics to your building model and show you how your building will look at the completion right over there at your desktop. And you can make a wise decision with respect to aesthetic of your building as such. We also have field engineers whose job is to ensure that the glass processed by the processor is up to the mark and your building gets the right quality of glass as such. And we set our standards very high compared to any American and European standards. So we always challenge ourselves to deliver better onto the projects. So that is a field engineer's responsibility to see that the quality of glass processed and applied onto your building is perfectly up to mark. We also have a free sampling and mock-up program as such to support the project owners wish to select a right glass for their projects. So thanks for patiently listening, and I'm looking forward to work with you all on your current and future projects. Please allow us to convert your visions and renders into reality. Thank you.
Thank you, Mr. Patel, for sharing the product range that you have at Gujarat Guardian Limited. I now request Mr. Abhay Bakre, Director General of Bureau of Energy Efficiency, to please share your views.
Thank you, Madam. Professor Dev Prasad, Mr. Pramit Patel, Mr. Pahuja, Dr. Agarwal, my colleague Sanjay, Seth, delegates attending this GRIHA Summit, 11th GRIHA Summit, ladies and gentlemen. It's indeed a privilege to address you here on the plenary session, post-lunch of 11th GRIHA Summit. Every year, we all assemble here to discuss about the different aspects of sustainability development, sustainable habitat, and I'm sure all of all of you take note of the developments happening in different parts of the world, the issues, the challenges, the views from experts, policymakers, and we take forward the journey towards our sustainable world. My colleague Saurabh Didi would have given you a detailed perspective about how BE is working in the field of building efficiency. But let me touch upon some of the broader points from the government perspective, from the policymakers' viewpoint, and also the kind of actions which is needed in coming months, in coming years, especially at the field implementation level. That's where the Bureau is aiming for the future actions. Two things have happened very recently in last 2 years. First, maybe almost 2 years back or so. Now in our country, and I'll talk about the Indian perspective, now electricity or the availability of electricity is no longer an issue. In other way around, we always call now that we are an electricity surplus country. What does it really mean? Maybe almost 8 to 10 years back, whatever was the connected demand or the peak demand, the installed capacity or the available capacity were slightly lesser than that, or maybe shorter. So there was a deficiency in the supply side, which has now been overcome. Today we are already reached 364 gigawatt, and even the peak demand which occurred somewhere about 2 months back, somewhere in August, etc., it was only 184 or 183 gigawatt. That means practically, even for the peak demand side, we have double the installed capacity. Our normal demand has somewhere stabilized between 140 to 160 gigawatt. Now, this is not just the numbers which is for the policymakers to decide or from the Power Ministry side. It also gives entirely a different perspective, because now what is going to happen is the installed capacity. It is going to be actually distributed to the consumers. And now the consumers have come, the second point, the consumers have come to a stage where the availability of electricity, at least the energy, the main resources, is a kind of taken for granted. Yes, they are going to have the 24 hours. We don't have a situation that even purchasing an air conditioner or purchasing different gadgets is a kind of a bothering thing, that yes, I can't put more than one air conditioner in my house because my electricity demand will shoot up, or there will not be enough load or given by the DISCOM. So most of the cities, even tier 2, tier 3 cities, the electricity availability has come to a 24/7 regime. Now what does it really mean? So that means there is enough flexibility in terms of the consumers deciding the kind of way they want to live, the kind of luxury they want to afford, the kind of homes, the kind of gadgets, the kind of other services they can aspire for. Now that puts a different challenge for our own building, the building professionals. Now they can have a different variety of homes, the different kind of appliances, and even any other kind of comfort or service conditions with that. Which means the architects will have more opportunity to offer the variety of homes, the variety of office buildings, as we have seen with Mr. Pramit Patel showing the different kind of the tall buildings. They have come up now. We were not talking about so much of variety in design, the construction, or even the overall perspective of the building or the accommodation or the premises. But now it has come to a stage that is, yes, in India also, we can afford any type of luxury, any type of aspiration. So the consumers are now free to choose what they want, to choose what they want to live. Now that puts the different thing which is the topic of this session, the energy challenge. How are we actually going to meet this varied kind of a demand? There may be a city which is going to have their population 20% increase, say in next 2 years, maybe for example Delhi or Jaipur or something. What will be the energy demand? Will it be 20% more? Will it be 40% more? Or will it be only 10% more? This will be entirely a different challenge if we talk about any other city somewhere else in the country. It depends on the kind of construction happening, the kind of space availability, the kind of devices or the gadgets or the appliances the consumers are going to purchase. Everything is actually leading to a different kind of energy challenge. Even as India as a whole, if we see, today only 7 to 8% of households are using air conditioners. What if it touches 10%? What if it reaches 15 or even 20%? It is estimated that by 2030, 20% of household will be using air conditioners. I believe it will be more than that. Because you have come to a different regime now. You have 24/7 electricity available, and very soon there will be a next level of transformation in the distribution company, which is something perhaps most of you are not aware. Now the distribution company, so far the generation was made flexible, the transmission, and now the distribution companies, maybe after 5 years, 6 years, we will have a distribution licensees or the electricity availability through different utilities, perhaps in a similar manner the way we today purchase the SIM card for Vodafone or Airtel, something like that. Maybe 20 years back we were only hooked up to either MTNL or a BSNL kind of a thing. And after 20 years we are having a portability. Anytime we can select the telecom operator, perhaps after 6 to 8 years or even depending on the transformation period, we may reach to a stage that even the electricity availability will be a kind of a free option for the consumer. Now what does it really mean? It means that every distribution company will offer you the most competitive price. And what will be the impact? Once you start having electricity or any other kind of energy at a most competitive price, you are going to purchase more and more appliances. You are going to have more and more energy demand. And that's where the energy challenge will come. Now what does it require? It requires an appropriate, complementary efforts to meet the demand. We don't want to go back to a regime again where there is a demand from the consumer and the suppliers of electricity or suppliers of energy are unable to meet that. We don't want this situation. It will impact our economy adversely. So the next solution is that yes, the consumer's aspiration will increase, the consumer's demand will increase, that's what we want. But at the same time, the overall impact on the energy supply side should be as minimum as possible. It should be optimized. And there is the requirement of a permanent thing, which is the construction of house to be made in such a manner on a long term it's giving either a near zero or kind of a net zero building, the net zero premises, etc. The things have to start now onwards. The ECBC, I hope you are aware, it starts with the minimum step of 20% efficiency. The ECBC has been notified already in 15 states and UTs, and very soon most of the country, most of the part in the country will be coming under regime where the new construction, at least for the commercial building, has to have a minimum level of compliance with the ECBC. That means every construction in the commercial side, maybe from an year or so, has to be a minimum 20% more efficient from the baseline. The second thing will be the residential code. The residential code It can't be met so easily in the mandatory because, as I said, there will be a different variety of designs coming up. We want the architects who have different designs, different experiments, and that's where to make residential code mandatory at so early stage will not be so much popular, and it will be detrimental to overall development of this particular building efficiency sector. So we expect that the energy efficiency in the residential side has to be promoted based on the each consumer's choice, or depending on how the architects are able to convince the consumers. Coming back to the implementation of ECBC on the commercial side, as most of you are aware, from the policy side or the regulatory side, it is the state government or the local bodies who have to actually monitor and regulate the construction of buildings. That's where the Bureau has published the code, and the state governments are able to actually deploy through their bylaws in the municipality or even the ULBs. But the work is not yet over. Just by notifying a law at state level or at municipality level is not over. We need to actually address the challenge how the consumer or the authority who is actually going to construct the building is able to enrich the idea of ECBC. They are able to get the benefit out of the ECBC provisions. Now that requires a massive capacity building of architect side, from the service provider, even from the material side. We need to have a good supply of material at field level available at affordable price. We cannot have a situation where the specific material which is used for ECBC compliance are available at a higher cost. That will again discourage the implementation of ECBC. On the other side, the compliance mechanism, the monitoring, the check test, the check verification have to be as smooth as possible. It should not delay the procedure. It should not discourage the procedure. So the ECBC compliance at state level is a Herculean task, and we are trying to get everyone, each one on board from the state level, even at the local level, to come forward and join hands with BE and the local state government to actually promote the ECBC implementation as early as possible. You would have already discussed the matter that how much construction we are expecting in next 10 years. So it is necessary that the ECBC compliance comes at every part of the country, and it is stabilized as early as possible, so that the next steps on the residential side can also start. The next thing I was discussing about the near zero or the net zero kind of a construction. BE has started some kind of feasibility. Can we have 100 net zero campus in the country? We want to know which are the most appropriate establishment where the near zero or net zero is more useful or perhaps most beneficial. So we decided we can have certain hospitals, certain airports, some university campuses, some townships, maybe some big railway stations or bus stands or like that. We would like to know whether the net zero concept is a universal or a general concept, or is it specifically for a particular sector is highly beneficial as compared to much less beneficial to other sectors. So such feasibility has now started from BE side. We are trying to engage competent architects and experts who can assist in that. But in near future, maybe net zero will be a new thing which we will be discussing, and it will be complementing the GRIHA effort of overall green building. There was a discussion on solar PV. Yes, the share of 365 gigawatt, as I mentioned initially, includes a larger share from the PV side, the solar side. Also, there is substantial share from wind side. Our overall target, which has now crossed, our target has crossed to 200. We achieved 84, but our next range of targets will be somewhere 400 or 450 total non-fissile capacity. In that regard, the second option of solar PV, which is the rooftop or a building or the demand side of solar PV, will be the next challenge. And I believe in coming years, the solar PV use at a building level, that is at the demand level, will be much more popular than the supply side, which has already come to a saturation. And in coming years, I think the building side solar PV installation will be given more priority from the policy side or from the government side. Last thing about the design construction and the design of envelope. The cooling demand, as I said, even if more 20% of household in India start using air conditioner, our overall air conditioning demand will actually will be 3 to 4 times than what we are having today. Now that will lead to us a very major thing is that today the industry consumption is about 48% in the overall energy basket. The second consumption is about domestic and commercial, all put together 34%. However, the massive construction which is expected in coming 10 years, coupled with the large scale adoption of air conditioning in the commercial as well as residential side, we expect that the building energy requirement will be the highest in the country by 2030. It will surpass the energy demand of industry sector, and that will be entirely a different situation than what we have today. Today the energy to the industry sector is supplied in entirely a different approach. It is supplied in a different regulatory framework. Whereas when it comes to the residential side and commercial side in the building sector, the energy will be supplied through a different channel. That means this entire ecosystem, the distribution system, has to be augmented. And that will have to take place in next 8 to 10 years. So this will be a new challenge for the energy side. So whenever the building efficiency goes up, it will actually slightly have solutions for the distribution side, thereby actually the energy demand will be stabilized by 2030. Else we are going to face again energy challenge by 2030 if we are not in a position to actually promote the use of green building, the use of energy efficient building, etc. Let me thank again the GRIHA Council for inviting me here and have a very useful seminar for these 2 days. Thank you.
Thank you, Mr. Abhay Bakre, for giving us an overview about the policy instruments that are being adopted at city and state level and at country level, what kind of codes are there and what can be promoted further to ensure that we do not face energy challenge in future. With that note, I would now like to call Mr. Ashwani Pahuja, Chief Sustainability Officer and Executive Director Manufacturing at Dalmia Cement Limited, to please share your views with us.
Shri Dev Prasad ji, Shri Abhay Bakre, Dr. Agarwal, Shri Patel, Shri Seth, distinguished delegates, a very happy afternoon to you all. I am here to share the perspective of cement industry and my company Dalmia Cements with regard to energy and climate actions, that the challenges which the industry is facing today and the overall climate challenges which the world or the planet is facing today. The Indian cement sector is today the second largest cement producer in the world after China in terms of production and capacity. But in terms of energy consumption, specific energy consumption, it is the best in the world. Much better than China and much better than rest of the developed economies also like Japan or Germany. In fact, it has been ranked number 1 since last more than 5 years, and World Business Council for Sustainable Development, through its cement sustainability initiative, they carried out the getting the numbers right project for all the countries, and based on that data generated, it was found that Indian cement sector, it was announced in 2015 at the Paris Climate Summit by CSI that today the Indian cement sector is the most energy efficient in the world as a country, as a whole. So that gave pride to the Indian cement sector, and one of the major factors for achieving this economy, energy efficiency, is the PAT scheme of Bureau of Energy Efficiency. In the first cycle of PAT, the industry overachieved their targets by almost 81%, and as a result of which in 2015 it was declared as the most energy efficient sector. While the energy efficiency has improved tremendously over the years, there are certain impediments which the industry faces, and I think I would like to share with you also today. For example, today the low hanging fruits have been already tapped by the industry, but it so happens that there are certain energy efficiency areas which need the support of government and policy makers so that the further improvements in energy efficiency can take place. Few of them are, I would like to highlight here, is that one is that the waste heat. Cement industry is a very high energy intensive process, and it requires heating of the materials to as high as 1500 degrees Celsius. And once we heat this in the rotary kiln, the exhaust gases are emitted at around 300 to 50 to 400 degrees Celsius, which are emitted as a waste gas to the atmosphere. And if we try to tap heat from these waste gases, it's very expensive process because it's a low grade heat, and the size of boilers becomes very large, as a result of which the costs are slightly on the higher side as compared to the conventional power generation projects. It is almost double as compared to conventional thermal power energy. So there are certain incentives which are perhaps required if we have to tap this waste heat, and industry has been expecting that this waste heat can be, because the waste heat recovery boiler is actually tapping the waste heat from the stack, which is indirectly going to the atmosphere, and tapping from the stack, or which is going to the atmosphere, taking it back into the cycle and then recovering the waste power from it. So as a result of which the industry expects that it is virtually equivalent to or a deemed renewable energy, because otherwise it would have gone waste. So if it is considered as a deemed renewable energy, in that case, if certain incentives are given, there is a potential of nearly 1000 megawatt of power from waste heat recovery. Presently, only inefficient units which are creating more waste heat, they are able to economically take advantage of this, and around 250 megawatt of waste heat power has been created. But we believe that in case certain incentives are available, this is the potential which the cement industry can tap from waste heat. Another important area is if we have to reduce the energy consumption, then switching over to renewable energy, solar power, wind power, and also to renewable biomass for fossil fuel switchover is very important. Now here again, I'll give you an example of Dalmia cement. At Dalmia cement, we have taken the commitment of becoming carbon neutral. Mr. Abhay Bakre mentioned that buildings, we are targeting buildings to become net zero. Similarly, at Dalmia cement, we have taken a target of becoming net zero, rather even carbon negative by 2040. As against most of the developing nations or developed nations taking a target of 2050, at Dalmia cement we have taken this target of 2040. And in this there are many major levers apart from energy efficiency and resource recovery as well as circular economy principles. The major commitment which we have taken is RE100, that is by 2030 we have committed to RE100 project, that is by 2030 we will switch over from fossil fuel based power to totally renewable power. Then next initiative is EP100, that is we will improve our energy productivity by 100% by 2030 in next 12 years. The third major milestone which we have taken is that we will switch over 100% from fossil fuel, that is coal and pet coke, to again renewable sources of thermal energy, that is mostly waste based thermal energy, alternate fuels, low carbon or carbon neutral fuels, as well as sustainable biomass. And lastly, switch over to carbon capture and utilization of all the carbon emitted through our stacks, which will be captured and then converted into useful chemicals and products for creating a circular economy. So here again, we expect that at the moment, the economies of scale are not existing for these kind of projects. So gradually, we expect that as the policies of the government also change, as there are more enabling policies for or incentives for development and scaling of these technologies, these things we believe that in next 5 to 7 years are going to become viable. Here I would like to share an example of Dalmia Cements, where in 2013 we installed about 8 megawatt of solar power. The power cost was around 17 rupees a unit, but it was taken as a demonstration project because our group believed that solar energy is the next future generation technology, and through the economies of scale, the costs are bound to come down. So as a pilot project, even though the costs were higher, the paybacks were not attractive, but still to gain experience, our group installed that 8 megawatt. And today, as you see, within 6-7 years, the cost of power has come down almost 1/5 or less than 1/5. Today we are talking of around 2.75 to 3 rupees a unit, as against 17, 16, 17 rupees. So that we believe that these type of economies of scale are going to emerge further. The cost of solar is going to further come down. The cost of the carbon capture and utilization is going to come down. There may be certain additional, because the today world is talking of carbon taxes. In India also, we already have certain implicit indirect carbon tax in the form of close to $6 per ton in the form of clean coal cess. People believe that in future, because of international pressure, this carbon tax also may be levied on other sectors also. And these type of enabling policies, for example, on solar now, I would like to mention here that when we take RE100 commitment, our total solar power requirement comes to close to 1000 megawatt. But based on policies existing today, we have our cement plants in 8 different states. Different states have their own policies. There is no single national policy on solar. So when we examined this and when we gave it to a consultant to examine to what extent we can install, today we find that less than 100 megawatt is today economically viable because of certain different state policies, whereas our total requirement is 1000 megawatt. So we are waiting for certain enabling policies when this will become possible, and for us to scale up our ambition to go in for RE100. The issues like, for example, net metering, particularly for private sector. If we have to go for captive solar, then we have to go outside our premises. In that case, the issues like net metering, transmission charges become very important. And then here we feel that distribution companies are better placed as compared to private corporates to distribute power or generate their own power, and banking of power. So these kind of facilities, we feel that once these become more enabling atmosphere is created, I am sure the private sector is going to come forward and take advantage of these, and then share their part also in national commitments of creating renewable energy. In addition to that, on biomass also, sustainable biomass, we have taken an initiative that while switching over from coal to renewable biomass and renewable alternative fuels, we can make use of the wastelands. Nearly 26 million hectares of wastelands exist in our country, which are sodic in nature, which are alkaline in nature, whose pH is close to 9 or above, where nothing grows except certain species of bamboo, which can be used as an energy plantation. And this energy plantation, if done sustainably through a precision farming, these can give a yield which can be 4 to 5 times higher yield as compared to other biomass. So we believe that this type of sustainable biomass, if certain enabling policies of making these wastelands available to private corporates or private sector through certain mechanisms, if that can be done, the sector is ready to come forward and do that plantation. That will not only result in creating additional reduction in carbon footprint, creation of reduction on dependency on fossil fuel. At the same time, it will also result in increasing, more than doubling the farmers' income, which is also in line with the national objective and with the sustainable development goals. So these are certain initiatives which we feel that it is now right time that private sector or corporates start rubbing shoulders with the government in creating enabling environments. And today we believe that certain groups are ready to take these type of initiatives, these type of challenges, wherein we can create these type of historical challenges. Now, for example, this 100% neutrality of zero carbon or carbon negative, it is the first of its kind by Dalmia Cements, which this commitment has been taken globally, not only in India. So that's also a matter of national pride also and prestige. So these kind of initiatives, we believe that private sector corporates are today ready to take, and then I'm sure that in the coming years we can see very encouraging results in the form of energy as well as energy efficiency and resultant reduction in carbon footprints as well as on climate action. Thank you. Thank you very much.
Mr. Pahuja, thank you so much for sharing inspiring work that you are doing and the initiatives that are being taken at Dalmia Cement. With that, I would now like to request Dr. Anna Agarwal, Fellow at Center for Policy Research, to share your views on the subject being discussed. Thank you.
Thank you to the GRIHA Summit for inviting me here. It's an honor to share this platform with this esteemed speakers and all of you delegates. Thank you. So in my presentation today, I'll be presenting some data around energy demand transitions, how and at what scale is energy demand changing, some data on how household appliance ownership is changing, and the resulting implications on the energy system, particularly the peak demand. I'll also be talking about the opportunities of energy efficiency and the role human behavior and local practices play in shaping final energy demand and the uptake of energy efficiency services. And lastly, some thoughts on what can we do. So energy demand is undergoing a fundamental transition. As you can see from the figure in the figure on the top, this is from Niti Aayog. Energy demand is set to increase significantly between 2012 and 2047. The share of building energy demand will increase significantly, but the largest magnitude increase is coming from the industrial sector. The figure at the bottom shows specifically the energy used for space cooling for different countries. The first set of bars here shows the change in space cooling related energy demand for India, how it's going to change in the next 30 years, and we see that by 2050, India is poised to be the world's largest energy user for cooling. This increase is largely going to be driven by increase in residential AC ownership in urban households, but also in rural households, we are seeing that they're starting to invest in medium to high power appliances. Some data on how demand for energy intensive appliances is increasing among urban households. The figure on the top shows appliance ownership in Rajkot among low income housing. The x-axis here is the asset index, which is a measure of households' overall assets or the household's ability to consume energy. And what we find here in the low income households in Rajkot, that even in the early deciles of the asset index, almost everyone owns a fan. As the household's overall assets increase, they start owning 2 or more fans. What is interesting is that TV is more commonly found in these houses as compared to fridges or coolers, even given the hot and dry climate in this region. The figure at the bottom shows cooling appliance ownership in Delhi NCR households. And the x-axis again here is an asset index, which is overall household assets. What we find again is that most households own a fan, almost all of them. The next commonly found cooling appliance in Delhi NCR is the cooler, which around the 4th decile people start owning a cooler. By contrast, AC ownership is only starts showing up in the highest decile of asset index. But as incomes increase, it's likely that this AC curve is going to mirror the cooler curve. So we saw some data on how energy demand is going to increase, how household appliance ownership is going to increase, and this has implications on the overall energy system. Most of you must know that Delhi utilities are facing a new peak, the summer nighttime peak. This is increasing year on year and has become bigger than the daytime peak. From our Delhi fieldwork, where we survey about 2,000 households on adoption of cooling services, we just did it this summer, we find indeed that over 85% of households turn on their AC right when they're going to bed. That's between 10 p.m. to 1 a.m. interval. The next common time for using air conditioners or coolers, we also look at cooler households, is in the afternoon between 1 and 4 p.m. So this shows that it's important to focus not just on appliance ownership, but also how people are using these appliances and what are the factors that is driving decisions on both ownership and usage. So I think my esteemed panelists spoke about the different energy efficiency measures and the value of energy efficiency, and it is indeed very critical to have these energy efficiency interventions to reduce demand and to lock in low demand patterns. The figure on the top shows that in the last 15 years or so, energy efficiency improvements have led to about 6% of energy savings. The largest of this comes from the industrial sector. Buildings and transport also contribute to the overall energy savings from energy efficiency. The figure on the bottom shows that due to inefficiencies in the overall energy supply chain, every unit of energy conserved on the demand side leads to multiple units of primary energy saved. So the x-axis here is for every unit of useful energy or the demand side energy that's conserved, what are the number of units of primary energy that you save. And we see that India benefits a lot more from energy efficiency compared to other countries. The question is, are we using the opportunities that energy efficiency offers to the fullest? The figure on the left shows penetration of energy efficient appliances in the low-income households in Rajkot. And indeed, due to Bureau of Energy Efficiency and EESL's initiative, we find that penetration of LED light bulbs in these households is very high, and it's directly linked to the Ujala scheme. But in fans and TVs, which are the next most commonly found appliances, the penetration of star-rated or energy-efficient appliances is minimal. We again look at what star rating are the households in Delhi opting for, and we find about 50% of households are going for a 3-star rated AC, and about a quarter are buying 5-star ACs. The number of appliances that will be bought for the first time is very high, and these appliances once bought stay in the household for many years. There's an enormous potential for making our demand transitions more efficient and the need for to replicate the success of schemes like Ujala. An important shaper of energy demand is behavior and local practices. In the Rajkot work, we find that households that have very similar appliance ownership, very similar physical building characteristics, show a large variance in energy consumption. So these figures show the variance around energy consumption for very similar households. We find when we control for structural variables, like your appliances, physical building, it helps explain about 30% of the electricity consumption variation. But accounting for behavioral factors helps explain up to 60% of why electricity consumption varies among similar households. Different people use energy very differently. So non-energy practices like adjusting clothing depending on weather, opening doors and windows, households using electricity saving strategies like occupying the same room when a cooler or AC is on significantly affects what the total demand is. Just some concluding thoughts. The impending energy transition offers a potential advantage. Since most of the investment in our cities, infrastructure, institutions, appliances, and behavior is yet to happen, there's an opportunity to make this consumption more efficient so as to lock in low consumption pathways for the long term. And we just saw that behavior and local practices have a significant impact on the final energy demand. So our energy interventions should account for these factors and look for ways to shape and influence behavior and practices.
Thank you, Dr. Agarwal, for beautifully presenting such a rich data in a very concise format and the concluding thoughts. I would now like to request Mr. Sanjay Seth, Senior Director, TERI, and CEO, GRIHA Council, to please share your views.
I'll take just 2 minutes. Esteemed panelists and my friends, esteemed audience. Much has been said by the fellow speakers on the dais, and I just need to make 2-3 very quick points in the interest of time as well. We all realize that as the urbanization is taking place, the challenges that it's throwing up on various sectors, including energy, waste, water, governance. We at the GRIHA Council are trying to see how we can overcome these challenges through design interventions to make sure that whatever we built in the future is not very resource intensive, and together with that, we and the GRIHA always believe that what gets measured gets managed. So that's our underlying principle. So we keep monitoring so that we don't consume as much as don't consume too much in the sense which puts a negative impact on the environment as well as puts pressure on the environment. So I think what Dr. Anna Agarwal presented in terms of figures, and of course the regulatory provisions that have been brought out by the Bureau of Energy Efficiency, as brought out by the Director General of the Bureau of Energy Efficiency, I think sum it up very well in terms of what needs to be done to make sure that as we urbanize, as the aspirations of the people grow, and how we can probably regulate this pressure or the resource intensive aspirational goals be moderated so that we don't grow on the same trajectory as we are growing in terms of infrastructure. So with those thoughts, I think I leave it to you all. I know there are other parallel sessions which are about to begin, which we would want you to go and attend as well. The remarks made by various panelists, I think Professor Prasad, I think brought it out very well as to, you see, I mean, you also brought out some very good facts and figures that you all are, how you are monitoring it, Sydney and in Australia, the work that you all are doing. So I think it's important, again, the underlying principles being that we need to monitor, gather as much data, and CPR, the way you presented that data, I think that was very, very remarkable, and I congratulate you for putting those numbers. So thank you very much.
Thank you, Mr. Seth. I would like to request Professor Prasad to please present the token of appreciation to all our dignitaries present on the dais. Mr. Abhay Bakre, Director General of Bureau of Energy Efficiency. A big round of applause, please. Mr. Pramit Patel, Business Development Manager of Gujarat Guardian Limited. I think we can be a little louder. Thank you. Mr. Ashwani Pahuja, Chief Sustainability Officer and Executive Director, Manufacturing at Dalmia Cement Limited. This was a good try. Dr. Anna Agarwal, Fellow, Center for Policy Research. Now we switch the role. Professor Prasad, I would request Seth sir to present you a token of appreciation. A big round of applause, please. Thank you. Thank you, Mr. Seth. Before we close, I would like to bring your attention to the coffee table on the dais, which has a unique surface made from new green new panel, product currently being developed in the UNSW microfactories. The panels are based on technology developed at the Smart Center UNSW to upcycle problematic waste, glass and textile. I now request everyone to please proceed to the thematic tracks. I'll quickly announce which tracks are being held where. In Tamarind Hall, we have Engaging Women in the Built Environment session is happening there. In Jacaranda Hall, we have the thematic track for Reducing the Global Carbon Footprint. In Silver Oak Hall, we have the thematic track Sustainable Low Impact Materials. And in Namaltas Hall, we have the thematic track 6, which is GWI Hackathon. Post which we would reassemble again in the same auditorium for the much awaited comedy by Mr. Anirban Dasgupta. Thank you. And for the tea and coffee lovers, you can please help yourself by going in the hub area and taking the tea and coffee there. And those who want to connect to us can post the learnings from this session on Facebook, LinkedIn, Instagram, and our Twitter page by using the hashtag GRIHA for all and 11GS. Thank you so much for being with us.